Welcome to Summarize Science, where we break down complex research into simple terms. AI image generators like Stable Diffusion are becoming incredibly powerful, but getting them to perfectly follow our instructions is a major challenge. The process of fine-tuning them with user feedback, a technique from reinforcement learning, is often incredibly slow and computationally expensive. This paper, Advantage-Weighted Matching, asks a simple question. Why is this process so inefficient, and can we fix it? Currently, the most popular methods for training diffusion models with reinforcement learning use an objective that's different from how the models were originally trained. This creates a disconnect, forcing the model to learn in a way that's not natural for its architecture. The researchers here established a fascinating theoretical link. They proved that the popular method, called DDPO, is secretly a form of learning from noisy or blurry data. Imagine trying to learn how to paint by looking at blurry reference photos instead of crystal clear ones. That's essentially what these AI models were being forced to do, which naturally increases randomness and slows down learning. This is where the big idea comes in, advantage-weighted matching, or AWM. Instead of creating a new, complicated learning process, AWM goes back to the model's original, clean pre-training objective. The method is elegantly simple. The AI generates a batch of images from a prompt. Each image is then given a reward score based on how well it matches the prompt. AWM then uses these scores as weights. It tells the model to pay more attention to the processes that created the high-scoring images and pay less attention to the ones that made low-scoring images. It's a direct, intuitive way to apply feedback without adding all the extra noise and complexity of previous methods. So, does this simple change actually work? The results are staggering. On the GenEval benchmark, AWM achieved the same high-quality score as the previous leading method, but with an 8-time speedup. It required 8 times fewer GPU hours to reach the same level of performance. When looking at other tasks like generating text within images, the results are even more dramatic. The paper reports up to a 23.6 times speedup on the OCR task with the SD 3.5 model. That means a task that previously might have taken nearly 24 days of nonstop computation could now be done in just 1 day. This isn't just a minor improvement, it's a fundamental leap in efficiency. So let's recap the key points. Previous methods for fine-tuning diffusion models were slow because they were implicitly learning from noisy targets, which increased variance and slowed convergence. The new AWM method unifies the fine-tuning process with the original pre-training objective, creating a cleaner, more direct learning signal. It simply reweights samples based on their reward, amplifying good examples and suppressing bad ones. The implication for the future is huge. This breakthrough could dramatically lower the cost and time required to develop more advanced, safer, and more helpful AI image generators. It makes cutting-edge AI research more accessible and could lead to faster innovation for everyone.